audible? Hello. Hello. Can anyone confirm that if I am audible or not? Hello, hello.
Yeah, it's audible.
Okay, thank you. Hello everyone. Good evening. So let's start. Let me share the screen. Just can you see the screen? So do you have any question from the previous class? You can ask now if you have any doubt. So this is class number 8. And it is 16th September. Okay. So we'll solve some miscellaneous problem, let's say from transport theory today, starting with group velocities and effective mass, and then we can solve few problems from density of states and yeah, Fermi functions of probability of occupancy of electrons. So I think everyone knows about group velocity and effective mass of electrons in a crystal. So let me just write down the formulas. Just, so the group velocity velocity is given by Vj equal to d omega dk, where omega is the frequency. So E can be written as equal to h per omega. E is the energy of the electron. So this omega can be given by the dispersion relation, and from there you can so omega is a function of k, and from there you need to derivative with respect to k, and you will get the group velocity. So this is the formula of group velocity, and the effective mass of an electron in a crystal, that is effective mass, which is given as m star. So m star is given by h bar square divided by d2e by dk square. So these are the two formulas. We will be using these two formulas to solve few problems. So the first problem, yeah. So this is a problem from previous year's net question. So yeah, let me write down the problem first. So in this question you need to find the effective mass of the electron in a boundary in a band structure calculation the dispersion relation for electrons is found to be epsilon k is given by beta cos kxa plus cos kya plus cos kza. So this is the dispersion relation of the electron. Here beta is constant, and a is the lattice constant. So the effective mass at the boundary of the Brillouin zone, of the first Brillouin zone, is, so there are four options. Option A is 2 h bar square by 5 beta a square. Option B is 4 h bar square by 5 beta a square. Then option C, okay, someone is waiting. Okay, so option C is h bar square by 2 beta a square, and option D is h bar square by 3 beta a square. So you need to calculate the effective mass. So this is the dispersion relation is given. Let's say if we call this as equation 1. So what you need to do is you need to find the m star for this electron. So first calculate d2 d by dk, and then calculate d2e by dk2, and then use this formula to find which of the options is correct. Then we can solve few numerical problem also. I hope everyone is solving, right? So this kind of problems arrives in any competitive exams. The dispersion relation will be given, and you will be asked to calculate the uh, effective mass. So everyone calculate dE dk. E is actually epsilon k, so d epsilon k dk, and then d epsilon k d2 epsilon k dk2, and use this formula that m star equal to h bar square by d2 epsilon k by dk2, and let me know what is the answer. Okay, so the effective mass at the boundary of the Brillouin. So at the boundary, we know that the value of the k value are plus minus pi by a. So use that also, that at the boundary kx and ky all are plus minus pi by a. So you need you also have to use that kx and ky equal to kx ky and also kz, sorry, kx ky and kz all are plus minus pi by a for the first Brillouin. So you have to put pi by a, pi by a, pi by a. For this point you have to calculate what is the value. So whatever you will get in terms of k, right, and kx ky and kz, the answer will be in terms of kx ky and kz, and ultimately you have to put kx ky kz as pi by a. So let me know the correct answer. The earliest you will solve, the more problem we can solve. Is it solved? Anyone? Just a double derivative, come on. Should not take that much time. So what is the correct option? No one could solve this.
Option D, sir.
Option D. Yes, correct option is option D. So it's nothing, just a double derivative, right? So epsilon k is given. Epsilon k is beta cos kxa. This is the answer, right? So beta cos kxa plus cos kya plus cos kza. So first calculate what is d epsilon k dk. That will be beta into a outside. Sorry. Okay, so it will be like a effective mass is case. So put sorry, the first thing you need to do is at the Brillouin you need to put all the values of k. So you can do more. So d epsilon k, then wait, beta into a is there, then d dk of cos kxa, not a, let's say a is there, plus d dk of cos kya plus d dk of cos kza. So beta, this will be minus sine kxa, 1a is outside, and then there will be d kx dk. So it's a chain rule, because it is a function of k is function of kx, ky and kz. So what we did is, we first did, so d dk of cos kxa, we did d dkx of cos kxa into dkx of dk. Similarly for the other also, so a will be outside, similarly we will get minus sine kya into dky dk minus sine kza into dkz dk. Now what is k? K is kx square plus ky square plus kz square over root over of this. So you can calculate anything, let's say any derivative with respect to kx. So it will be 1 by, it will be kx by root over of kx square plus ky square plus kz square, and this will be kx by k. That means if you calculate dkx by dk, it will be kx by k. So from, so there d epsilon k dk will be beta into a. So dkx dk will be k by kx, and minus sign will be coming outside, so sine kxa plus k by ky sine kya plus k by kz sine kza. So this is the first derivative with respect to dk. Similarly you can do for you can calculate d2 epsilon k by dk2. So I think it will be getting difficult for, so it will be d dk of k by kx into sine kx. Let's say we want to calculate the first component. So it is, there is 3 component. So the first one is just 1 by sine kx sine kx a by kx plus then d dk of 1 by kx so into k sine kxa, and ultimately k by kx d dk of sine kxa. So I thought it will be easier, but yeah, the differentiation is really cumbersome. this is kx, and yeah, this will be minus 1 by kx square into k by kx into k sin kxa. And finally, so we already calculated what is sin kxa, the differentiation. No, we didn't. So it will be plus k by kx, 1a is there, sin kx is cos kxa, into so ddk of kx of k by kx. Since we want to calculate at kx equal to pi by a, so sin kxa will be sin pi, that means 0. So everything which comes with sin kx by a, those things will gets cancels out, only the cos kxa part will remain. So for the first thing, we'll get minus beta a, so d2 epsilon k dk2 at pi by a is pi by a pi by a pi by a will be, so if everything is pi by a, then k will be, k is root over of pi by a square plus pi by a square plus pi by a square, which is root 3 pi by a. Also there is k square, that is 3 pi square by a square. So it is k square is 3 pi square by a square into a divided by kx square, and kx square is pi square by a square, and cos kxa is cos pi by a, which will give us minus 1. And there was also minus beta a is outside, so minus beta a. Since everything is equal, okay, at the boundary we will get another 3 factor here, so ultimately we will get pi square is cancels out, we will get 9 beta a square. Is it so? So what about others? Everyone, so who calculated this? Renuka Devi, did you calculate like this or some other way? So this is what we get, d2k epsilon dk. Now we have to do is m star, which is h bar square by d2 epsilon dk2 at pi by a pi by a pi by a, and this value will be h bar square by 9 beta a square. So did I do anything wrong here? The answer should be h bar square by 3 beta a square, and I am getting 9 beta a square. So have I done anything wrong? Hello, am I audible? So Renuka Devi, you said you got option D. Can you explain how did you calculate it? Because I think I have done from this like d epsilon k dk, everyone got this value or got some different value? Up to this it is fine, right? Then we need to calculate d2k d epsilon k, and what I did is I first considered this component. So let's say for this component, so because everything is similar, just in terms in the place of kx there is ky and kz. So if I want to calculate this, so this will give us sine kxa by kx, and dk of dk is plus ddk of this, so this will go to 0. We'll left with this value only, plus k by kx into ddk of sine kxa, and we'll get ka divided by kx into, so sine kxa is cos kxa, and we'll have another term which is dkx dk, and so dkx dk is what? Dkx dk is just k by kx. Dk dx is kx by k, so dk is k by kx. So I think it is fine, right? So it is, so it will be k square a by kx square into cos kxa. Okay, if we write it in the down, k square a by kx square into cos kxa. And k square is kx square plus ky square plus kz square. Everything is at the boundaries pi by a. So we'll get k, which is pi by a square plus pi by a square plus k square is 3 pi by a square. That is also fine. So d epsilon k dk2. I don't think anything is wrong there. I think we are getting, yeah, I am getting h bar square by 9 beta a square is, but I don't see any option like this. Does anyone see any mistake in the calculation? Can you point out? Hello. So Renuka Devi, you said you calculated it and you got option D. So can you tell me how did you solve it? dk রেসপেক্টে করছিস না, k is a function of kx ky kz, আলাদা করে kx ky kz করে যোগ করব, আলাদা করে বড় হয় না, চেইন রুল করতে হবে. I don't know if the answer is correct or not. So we'll look into this problem later maybe, because this none of the options are correct from here, but that's how you have to do it. Like this is the right way to do it, right? So I'll look into this problem later, but I'm getting h bar square by 9 beta square. If someone gets the correct answer, please let me know. So you can move to a different question. Yeah, so the next question is also to find out the effective mass, and the energy of an electron in a band as a function of its wave vector k is given by ek equal to ek equal to e naught minus b into cos kxa plus cos kya plus cos kza, where e naught and b and a, all of them are constants. Then the effective mass of the electron near the bottom of the band is so option A, it is 2h bar square by 3ba square. Option B is h bar square by 3ba square. Option C is h bar square by 2ba square, and option D is h bar square by ba square. So if you understood the last question, then you can definitely solve this one. So let me ask, did you understand how did I solve the last question, or do you have any question, any doubt you can ask? Because you need to solve this question by yourself, because if I solve it, then it will not help you, right? You have to solve this. Please solve this problem. So in this question, in the last question, it was asked to find the effective mass near the Brillouin zone boundary, but here it is asked to calculate the, so we in the last question we took kx, ky, kz as pi by a because it was in the boundary, but now it is near k tends to 0, so you have to take the limit that kx, ky, kz all are going to be 0. So at that limit, you know that cos x equal to 1 minus x square for small x if x tends to 0, and sin x equal to x for x goes to 0. So with taking these two limits, please calculate this and let me know the answer. So please solve the problem. I'll get some water, just 2 minutes. Hello. Has anyone solved? Look, if you have any doubt, you can ask, but you have to solve it yourself, right? It will not help you because if I just solve this problem, so okay, so whatever. Let me solve this. So ek is e0 minus b of cos kxa plus cos kya plus cos kza. So the effective mass near the bottom of the band. So near the bottom of the band, that is near the bottom of the band, k tends to 0. That means you can approximate that kxa is nearly equal to 1 minus half kxa square. Sorry, 1 minus x square by 2. So that formula is there. And also you can approximate kya to be 1 minus half ky square, and cos kza as 1 minus 1 minus half kza square. Then what will be the dispersion? From there we will get that E of k is E naught minus b into 1 minus half kx air whole square plus 1 minus half ky whole square plus 1 minus half kz air whole square. So this is what we will get. You can also write this as E naught minus beta into 1 plus 1 plus, so 3 minus half, if you take half, a square by 2 is common, then you will get kx square plus ky square plus kz square. So I have taken common from this and this, a square by 2, and we will left with this. Ultimately we will get E naught minus 3b plus a square b by 2 into k square, because kx square plus ky square plus kz square is k square. Then the effective mass, you know that m star is h bar square by d2e by dk2. So E is E naught minus 3b plus a square b by 2 k square. So derivative with respect to k is a square bk. 2k 2 cancels out, so a square bk, and d2e dk2 is a square b. So what will be m star? So m star is h bar square by a square b. So which option is correct? Option D is correct. So this is the right option. The correct answer is option B. Sorry, option D. So that's how you have to solve this kind of questions. Anyone has any doubt, you can ask now. Does anyone have any doubt? Am I audible? I don't know. Is my microphone working fine? I don't know. Let me check. So please response. Am I audible? You can write in the chat box also. Hello. Okay. So I guess no one has any doubt. Then let's solve another problem. So here we have the energy. I'll write the question. So it's like the same previous question, but you have to calculate it. It's a numerical problem. So the energy near the valence band H of a crystal is given by E equal to a k square minus a k square, where a is equal to 10 to the power minus 39 joule meter square. So an electron with wave vector k equal to 10 to the power 10 kx meter inverse 10 to the power 10 kx meter inverse is removed from an orbital in the completely filled valence band, is removed from the completely filled determine the effective mass. Okay, I think it will be better if we just stop here and calculate the effective mass. So calculate the effective mass of the electron. Calculate the effective mass of the electron. So this is the problem. Let me know the answer. So this is the same question. You need to do double derivative of energy and then put the value of E and h bar square, A and h bar, and then calculate it. Is anyone trying at least? Well, so let's do this. E is given as minus ak square. What you need to do is dA dk and d2 e dk2, so you will get minus 2 ak, and then d2 e dk2 is minus 2a. Then what will be the effective mass? M star will be h bar square by d2 e by dk2. Then you will get minus h bar square by 2a. So the value you already know. The value of h bar in joule is h 1.05 into 10 to the power minus 34 joule second square divided by a. A is given in the question 10 to the power minus 39 joule meter square. So 2 into 10 to the power minus 39. So it's in kg, right? Because everything is in SI unit. So let me do it. Okay, so 1.05 square divided by 2, so 0.55 is 0.55, and 34 into 2 minus 13 29 20 minus 30, so 5.5. It is minus 5.5 into 10 to the power minus 30 kg. So this is the effective mass for this electron. Now we can solve a problem from finding group velocity also. So since we already have solved 3 problems from the effective mass, now let's solve a problem to find the group velocity. Given the tight binding dispersion relation, Ek is E0 plus a sine square ka by 2, where E0 and a are constants and a is the lattice parameter. A is the lattice parameter. So what is the group velocity of an electron at the second Rayleigh zone boundary? Where 4 options are 0, B is a by h, C is 2a by h, and option D is A by 2h. So you know the formula of group velocity Vg, which is d omega dk. So here if E is given, then uh, if E is given, then the group velocity's formula will be Vj equal to 1 by h bar dE dk, because you know that E equal to h bar omega. From there you can calculate dE dk, and then at the second Brillouin boundary. So first Brillouin boundary is at plus minus pi by a, so the second Brillouin boundary will be plus minus 2 pi by a. So at 2 pi by a you need to calculate what is Vc. So this is one problem you need to solve, and since there is one more interesting question from that effective mass, so please solve these two problem. Another question, so this is 4, then this is 5. There is one more question from this effective mass. So after this we will be done with this problem of effective mass and group velocity, then we'll move to some different problems. So the dispersion relation of electrons in a three-dimensional lattice in the tight binding approximation is given by epsilon k is alpha cos kxa plus beta cos kya plus gamma cos kza, where a is the lattice constant. And alpha, beta, and gamma are constants with dimension of energy. Constants with dimension of energy. So the effective mass tensor. So basically effective mass is a tensor, and you need to calculate the tensor at the corner of the first Brillouin zone. So Bz means Brillouin zone, that is you need to calculate it at pi by a and pi by a, which is given by, so there are 4 options also. A is h bar square by a square minus 1 by alpha 0 minus 1 by beta 0, then 1 by gamma. This is option A. Then option B is option B is h bar square by a square minus 1 by alpha minus 1 by gamma beta, and only there will be one minus sign. Then option C is everything with positive sign. everything with positive sign. And finally option D is h bar square by s square. Here also this is 1 by alpha, 1 by beta, and minus 1 by gamma. So first calculate this problem and then we will go to the group velocity problem. So then we will finish with the effective mass problem. So effective mass is basically a tensor. So in this effective mass tensor, for your convenience I will write the tensor here. In the tensor form it is h bar square by, sorry, it is just mxx star mxy star mxz star. Similarly myx star myy star myz star and mzx star mzy star and mzz star. So this is the matrix, and for a given element can be written calculated as, let's say, mij star h bar square by d2e dki dkj. So let's say mx, you want to calculate mxx star. So mxx star can be calculated as h bar square by d2e by dkx or dkx2. Then if you want to calculate, let's say, mxy star, it will be m d2 dkx dky. So in this way you have to calculate all the components of this tensor and find which of these four options is correct. Please calculate this by yourself, and I have to really attend this call, so I'll be back in 5 minutes. Please calculate this. So this is the so this is the question, and you have to follow from here. So I'll also write the write down the dispersion. Let me see if I can show all the screen at a time. It's still difficult, but yeah, maybe it will help. Hello. So what is the correct option? If anyone has calculated, let me know. So you have to calculate all the components here of this matrix. Let's say for the first one, you have mx6 star. For that you have to calculate del 2e del kx2. What is e? E is given by alpha kxa plus beta cos kya plus gamma cos kza. Yeah, so this is our energy cos kz. Then what will be del a del kx? It will be minus alpha a sin kxa. And what will be del 2e del kx2? It will be minus alpha a square cos kxa. So what will be this value at pi by a, pi by a, pi by a? So this value at pi by a will be at pi by a, pi by a, pi by a will be minus alpha a square into cos pi, that is minus a, so alpha a square. That means m x6 star is h bar square by alpha a square. So alpha square h bar square a square is you can take out and you are left with 1 by alpha. So you can already rule out some options. Let's say option A and option B cannot be correct because you have h bar square a square into 1 by alpha for the mx6 star component. So only option C or option D can be correct. So in option C and D you don't need to calculate all the component. You can see that only these components are different. So you just need to calculate what is mzz star. If you calculate mzz star, then only you can say which is the right option. So zz star is del 2e del kz square. And you can show similarly. So what was E? E was alpha cos kxa plus beta cos kz kya plus gamma cos kz. Then what is del E del kz? It is gamma a minus sin kza. And del 2e del kz 2 is minus gamma a square cos kza, and this value at pi by a, pi by a, pi by a will be cos kza is minus 1, so it is just gamma a square. So again you are getting alpha square a square into 1 by gamma. So every component will be positive. That means option C is correct. So we will get, so correct option is so. Is there any question? If not, then we'll calculate the group velocity for this problem. So let me add a page. So in this problem, that given the tight binding dispersion relation ek equal to e0 plus a sine square k by 2, where e0 and a are constants and a is the lattice parameter, what is the group velocity of an electron at the second Wilson boundary? A, B, C, D, all are, these are the options. And so as I have already mentioned how to calculate the group velocity, so ek is given, ek is e0 plus a sine square k by 2. Then d decays a into a by a into another 2 factor into sine ka by 2 cos ka by 2. I think I'm correct. So this 2 by a factor is coming because okay, so it is a by 2, so not 2 by a. So a was there, this into a by 2. Is it correct? Then what to do? So the group velocity is and it will be a 2 cancels out, so we will have a sine square k by 2, so 2 sine, yeah, I think right. So a sine k by 2, what we will have is a sine ka by 2 cos k by 2. Because this 2 and this 2 gets cancels out. Then in one dimension the below zone boundary is at plus minus a by a, and the second below zone, the second below zone boundaries lie at plus minus 2 pi by a. So dek at 2 pi by a is a sine k is 2 pi, so sine pi into cos pi. Now sine pi is 0, so the overall thing will be 0, and the group velocity is defined as as Vg is 1 by h bar de dk. So since d dk is 0, Vg is also 0. So the group velocity at the second boundary is second Wilson boundary is 0. So which of these options is correct? Option A. So the correct answer is option A. Is there any question? If there is any question, you can ask, else we'll solve few different problems. So let me stop sharing. So this, from these 5 problems, if you have any question, you can ask. solve few different problems from here. So let me open this so just give me a minute. So this is oh sorry, this is not the one I'm looking for, because this due date is still not there. So I'll solve assignment 7 of, because the due date is already over, so we don't have any problem actually solving this. Yeah. So I think assignment 7 was solved by everyone already. So let me share the screen again. So these are few simple problem from the assignment 7. So the first question, which will be the question number 7. So occupancy of electrons in bands. You have to find out the probability of occupancy of energy level E by an electron for E much less than EF. EF is the Fermi energy. So when the energy is much less than EF, what will be the occupancy of the electron? And the options are 1, B is 10, C is 100, D is 1000. So please do this question. Find out the occupancy of the electron of energy level E by an electron for energy which is much less than the Fermi energy. Calculate this and let me know. Yes, it is 100%, but that means occupancy is 1. So the correct option will be 1, but in terms of percentage it is 100%. So how will you calculate it? So the Fermi-Dirac distribution function Fe is 1 upon 1 plus exponential epsilon minus epsilon F by kBT. So the energy epsilon is much less than epsilon F, which implies that epsilon minus epsilon is almost, this tends to minus infinity, and you know that exponential minus infinity is 0. So these terms will vanish and f of E is 1 upon 1, which is 1. You also know from this curve that at 0 temperature it is like this. So this is f of E with energy, This is the Fermi energy epsilon F, and at finite temperature it will be like this, where the occupancy is 0.5, this is the 0.5, this is 1. So at this is for T equal to 0 Kelvin, and this is for T Kelvin for a finite temperature, right? So you can see that when energy E is much less than epsilon F, let's say from this area, around this area, this is almost 1. So also we can see from this calculation that the occupancy is 1. Now the second question is the Fermi level of potassium. Second question is our 8th question. This is a small problem. The Fermi level of potassium, Fermi level for potassium is 2.4 electron volt. Then calculate the velocity of the electrons at the Fermi level, and these are the option 8.6 into 10 to the power 5 meter per second. Option B is 9.2 into 10 to the power 5 meter per second. Option C is 4.2 into 10 to the power 6 meter per second, and option D is 5.2 into 10 to the power 7 meter per second. Yeah, so calculate the Fermi velocity. Fermi energy is given. I hope this question is not solved in the last class, because this kind of questions we solved in the last class, but let's see, this particular problem I hope is not solved. So this was from Fermi temperature. So we did not solve this problem, so we can, so please solve this problem. If you were present in the last class, you can definitely solve this one. Fermi level is given, you need to solve. Option B. Yes, this is option B. So what you need to do is, your Fermi energy is given, which is 2.4 electron volt. Then you have to calculate Vf, which is given as 2 epsilon F by m, and it will be given by 2 into epsilon F is 2.4 electron volt. You can convert it to joule, that is 10 to the power minus 19 joule, divided by m, and m is 9.1 into 10 to the power minus 31 kg in meter per second. So if you calculate this, I haven't calculated, but you can definitely calculate this. So let me do the calculation. 2 into 2.4 into 1.6 divided by 9.1, 0.84, so it is root over of 0.844, 0.844 into 10 to the power 11, sorry, not 11, 12. So square root of 0.844. Okay, this meter per second. So you will get 9.2 into 10 to the power 5 meter per second. So the correct option is option B. I think you already solved assignment 8 because you had to submit it in 13th 30th of September 13th of September. So if there are any question you couldn't solve, you can ask. We can solve that particular problem rather than solving all the problems. I think you already solved these problems because its due date is over, right? So if there are any particular problem you couldn't solve, you can ask. Is there any problem from assignment 8 that you couldn't solve? I can share this from here. So yep, I think this is assignment 7. Sorry, assignment 7, not assignment 8. So can you see the screen? So tell me if there are any problem that you could not solve. So question 1 and 2 is already solved. Question 3 is I have solved in the previous class. Question 4 is also similar. So lambda you can calculate, right? The de Broglie wavelength you can definitely calculate. So from these questions, if you have any doubt, you can ask. So if you really solve every problem, can you solve question number 9?
Sir, question number 1 and 10 have the same concept.
Yes, exactly. Question number 1 and 10 have the same concept. So question 10's answer is also C, right? Because the energy difference is 4 electron volt, and if you divide by kBt, that is very a large number. So exponential of minus of large number is 0. So 1 by 1 plus 0, it is 1. So option C is correct. So if you have understood every question or submitted, then please solve question number 9. The Fermi level of copper is 7.2 electron volt. The maximum velocity of free electron at 0 Kelvin is what? So the answer is already given, but you please explain how you calculated it.
Sir, ninth one?
Okay, so what I was getting is 1581, that is 1581 kilometer per second. So option A and B both are like close to it, but they have chosen option B. Option B is the most. Option B is the closest one, so I think option B is correct. But
Actually, sir, question number 6 and 9, just sir, reciprocal one.
question 6, estimate the mean free. Question 6 is estimate the mean free path of electrons in pure copper at 4 Kelvin. The collision time for phonon scattering at 4 Kelvin is given. The Fermi energy level for copper is 7.2 electron volt. So here also you need to calculate VA, and you multiply with tau. Tau is already given in the problem. Then you can calculate the mean free path. So mean free path is actually velocity into tau. Yeah, so almost similar. So you need to use that formula, that Vf equal to root over of 2 epsilon f by m. So using that formula you can calculate both of them. So I'm not going to solve this. If you have any difficulty solving, you can ask later. So these are almost similar kind of problem. So you don't have any doubts from here, right? Okay, so we'll maybe solve something different. Let me check. We're solving this problem. Yeah, so calculate this one. Let me write down first. Question number 9. If the Fermi energy of copper is 7 point.
Screen is not visible, sir.
Oh, okay, sorry, I think I have not. If the Fermi energy of copper is 7.2 electron volt, calculate the de Broglie wavelength of the electron. Given that Planck constant H is 6.626 into 10 to the power minus 34 joule second, and mass of electron, that is Me, is 9.1 into 10 to the power minus 31 kg, and also 1 electron volt is 1.6 into 10 to the power minus 19 joule. It is also given. So, and the options are 2.12 angstrom, option B is 1.52 angstrom, option C is 4.57 angstrom, and option D is 9.22 angstrom. So calculate the de Broglie wavelength for this and let me know the answer. So what is the answer? What is given here? The Fermi energy is given. Epsilon F, which is 7.2 electron volt. Then you have to calculate the de Broglie wavelength. So de Broglie wavelength lambda is equal to H by P. So you know that P is from the energy. So P square by 2m is E. That means P equal to root over of 2me. So if you replace this, then you will get that lambda equal to H by root over of 2me. So E is given here. Energy E is 7.2 electron volt. This is the Fermi energy. Then this can be converted into joule. M is also given 9.1 10 to the power minus 31 kg, and H is given as 6.626 into 10 to the power minus 34 joule second. So put these values in the formula. So you will get lambda equal to 6.626 into 10 to the power minus 34 divided by root over of 2 into 9.1 10 to the power minus 31 into E is 7.2 into 1.6 into 10 to the power minus 19 joule. So if you put all the values, then you will get, then what will be the, so let me check. Everyone calculate this in the calculator. 7.2 into 1.6, 2.2 into 9.1 7.2 into 1.6 into 10 to the power minus 19 minus 31. So 2.09, it will be 6.626 into 10 to the power minus 34 divided by root over of 2.097 into 10 to the power minus 48. So do the root over of 2.09 into 10 to the power minus 48. This is in meter, yes. So we'll get 6.626 into 10 to the power minus 34 divided by 1.4445, let's say 1.44 into 10 to the power minus 24 meter. That means 6.626 divided by 1.44, that is 4.6 into 10 to the power minus 10 meter, which is 4.6 angstrom. So 4.57 angstrom. So option C is correct, I think. So someone has said option A, but I think option C is correct. What about others? Did anyone else calculate? Yeah, so option C is correct. It's nearly about 4.57 angstrom. The correct answer is option C. Yeah, so option C is correct. So can you calculate this problem? This is also from the assignment. So this is a question number 7 of assignment 7. Oh my god. This is 9. The probability of finding a free electron in Ag at 300 Kelvin at an energy level 1.02 EF is Fermi energy EF for Ag 5.5 electron volt and Boltzmann constant kV is equal to 1.38 into 10 to the power minus 23 joule per Kelvin, and the options are A is 0.512, option B 0.117, option C is 0.014, and option D is 0.005. So can you calculate the occupancy and let me know. So basically you need to calculate the familiar distribution function for the energy 1.02 EF. Okay. So you have to calculate the familiar distribution function, which is given by 1 plus exponential E minus EF divided by kBt. So you can already calculate what is kBt. Now kb is 1.38 into 10 to the power minus 23, and T is 0. T is 300 Kelvin, and since the energy is also given in electron volt, you can convert this to electron volt. So you just divide this by 1.6 into 10 to the power minus 19. Then this kVt will be in electron volt, and this is 0.026 electron volt, I think. Okay, let me still calculate this. I think we have done this in the previous classes also. So 1.38 into 300 and divided by 1.6 into 10 to the minus 4. So 0.026, yes, this is correct. And E is, so 300 at energy level 1.02 EF. So E minus EF will be 1.02 EF minus EF, that is 0.02 EF, and EF is given as 5.5 electron volt. So what will be the value? 0.02 into 5.5, that is 0.11 electron volt. So F of E is 1 by 1 plus exponential 0.11 divided by 0.026. Then what is the value? So exponential, I can't, okay, let me check. Exponential 0.11 divided by 0.026, something of 68.77. 1 by 1 plus 68.77, which is equal to 1 by 1 plus 68.77. 0.014, 0.01433, 0.014. So option C. So you don't need to write all the decimal places. So the correct option is option C, 0.014. So everyone got this answer or some different answer? So this is how you calculate the occupancy or probability of an electron to be at some state, some energy state. Oh, so till now, if some of you have any question, you can ask. Because it's already 7, so you will not solve any new question. You can ask any doubt from any of these questions we have solved today. If you have any question. So does anyone have any question, or we can end the meeting? If you don't have any question, we'll end here, okay? So thank you for joining. Bye.